Okay, so now we're going to talk about bond pricing. So bond has two parts to it. It's got the coupon and it's got the par value. So the way that a bond would work is that, so let's say, for example, I had a bond, let's say I had a $100,000 bond and that was a face amount. Let's say $1 million bond because that's what I typed. $1 million bond and that's the face amount. Interest rate, 10%. Let's say the term is, 10 years, paid semi-annually, so twice per year, 20 years. So what that would actually look like, you know, what that would actually happen if you buy this bond. Okay, if you invest in this bond, and let's say that the bond started on January 1st, 2020. That means that every 6 months for 10 years, that's a total of 20 payments. So we got payment one, payment two, interest payment, and so on, all the way down to 20 payments. Okay, so every 6 months. So what would happen in the first place is if I'm the corporation, I'm selling this bond, I receive either the $1 million, or it depends if it had a premium or discount. We'll talk about that later. I'd receive $1 million, and then I would pay interest. How much in interest? Well, the interest is semi-annual, so I can figure the interest payment by simply taking the $1 million times 10% divided by 2, because it's 2 of them per year, which is $50,000. So this company is going to be paying $50,000, or if you're the one that owns it, you're going to be receiving $50,000 every year for the next, or every 6 months, excuse me, for the next 10 years. Okay, so that would be how that would work. Now, to value, and then by the way, at the end, so here at the very end, actually it'd be the same date as that, you would then receive also the $1 million par value back. So it's kind of like, if you think about it like a loan, it's a loan where you're paying interest only for the whole term, and at the end you're paying the principal back. So that's again why the interest doesn't change, by the way, because your outstanding principal is always the same. In this case, it's always $1 million. So I'm paying $50,000 or receiving, again, if you're the investor or the corporation. But let's say I'm the investor in this case. So I'm receiving $50,000 a year every year, twice a year actually, for 10 years. And then at the end of the 10 years, I'm receiving my $1 million back. So when I'm looking at pricing this, I want to know what the value of this $50,000 6 months from now is today, and what this $50,000 is a year from now today, and this one a year and a half, and this one 2 years, and this one 3 years. So I need to know what the value of those is today if I was paying 10% interest. I also want to know what the value of the face amount is 10 years from now, compounded semi-annually, present value of that back to today. If I need to do an additional present value video, that's fine. You should have learned this in financial accounting, probably a little bit managerial finance. Time value of money should be a familiar thing to you. If not, I do have videos on this that I can send you. So if this is all new to you, let me know and I can send you additional videos for this. But I'm going to work off the assumption that we understand the present value functions. So how we do our bond valuation is we find the present value of the coupons, so that's all those $50,000 payments in my example, and we find the present value of the par amount, and then we add those two together, and that gets me my bond price. Okay, so they're using the annuity factors here. I'm choosing to use the present value function in Excel instead. So let's look at these two. So I've got 2 bonds. Oh, and by the way, I should mention the interest rate is the coupon rate. The market rate of interest, also known as the discount rate, is the rate that you would consider similar bonds with similar risks that they're going for right now. So what happens is if I have a difference between my market rate of interest and my coupon rate of interest, then I am going to end up either selling this bond for more or less than the face value based on that. If those two numbers are equal, then I'm going to sell it for exactly the face value. So, so first things first, let's do this bond here. Let's do this one. So we got a 4-year maturity, 5% coupon rate, 8% discount rate, a par value of $1,000. So my par value is 1,000. My term is 4 years. I assume it's going to pay semi-annually. I don't know if it says, but I assume that it is going to pay semi-annually. Yeah, it doesn't really tell me, but we'll assume that it does. That it pays semi-annually. And the interest rate on the bond is coupon rate's 5%, discount rate's 8. Discount rate is 8%. So $899.01. There's rounding issues here, but mine actually is more exact than that is. But that is the present value of that. Now, what you're going to see is that bond A, our discount rate is higher than our coupon rate. So we're going to have to sell that at a discount. And it makes sense that I sell at the discount because if the discount rate is 8%, that means that I can go find other bonds of similar risk on the market that will pay me 8%. If that's the case, I'm not going to buy these bonds that only pay 5. Why would I buy a bond that pays 5% when I can find other bonds, very similar bonds that pay 8? And the answer is I wouldn't. So for that reason, I can't sell this bond for $1,000. Instead, I have to sell this bond for what will make the effective interest be 8%, which means I discount the bond at 900.64. In their case, my number was 899.01. I discount to this price because what that's going to end up being is if I figure the interest on the actual price I received, it's going to return 8%. The yield's going to be 8% on this bond, even though it's only paying 5%. Why? Because I'm still paying the $25 in interest, like this $1,000, but I've only received $899. I didn't receive $1,000. So the return is actually going to equal the market rate. The other thing that's interesting about this is if the market rate equals the interest rate, coupon rate, if these two numbers are equal, the present value of this bond is exactly the face value of the bond. So if these are both 5%, it comes out notice exactly to $1,000. If they're both, doesn't matter what the number is, if they're both 10%, present value comes out to exactly $1,000. If the market rate of interest is higher, it is discounted and it comes out to lower or less than $1,000. But if we do the opposite, if the market rate is, so we talk about how discount works and why, okay, I'm not going to buy these bonds because they're only paying 5% when others of similar risk are paying 8%. So I'm not going to buy these bonds. Well, if I am the opposite, if I am paying 8% on my bonds, but the market, the rest of the individuals are only paying, the rest of the other companies are selling their bonds and they're only paying 5%, again, of similar risk and all the other elements being the same, then I can charge more for mine because people are willing to pay more to get an 8% return or to get an 8% coupon. So I can charge what's called a premium for that bond. And both are done through the present values of the bond calculation here. So I'm going to rewrite this. I'm going to rewrite this function so that you can see how it's written. So you can hopefully write it for yourself. This present value of a bond calculation. So I'm going to go equals PV. And I'm going to open my f(x) function because it's easier to see. So the first thing is the rate. Okay. So the interest rate is the interest rate per period. For example, 6% divided by 4 for quarterly payments. Well, this is semi-annual. So I'm going to take the market rate of interest divided by the 2 compounds per year. Oops, not done. Sorry. So market rate of interest divided by 2 per year. M per stands for the number of periods. So how many payments is there during the investment? Well, the answer to that is it's a 4-year bond with 2 payments per year. So I can multiply those 2 to get the number of payments. So 4 times 2, which is going to give me 8. And I'm building it like this because now I can change all these things and this will calculate it for me and I won't have to go back and recalculate these things all the time. So the payment is, I have that already calculated as the interest payment here. Okay, the future value is the principal or the face value. And the type, I just put a 0 in here. That's just whether it happens at the beginning or the end. Whoops, let's move it here. Future value, which is the face amount. Say that way. Okay, so I just redid the same calculation. So now all you have to do with this, if you build it the same way I did, is you just have to change those numbers I've highlighted. Everything else should calculate. Now, what I did do here is I took the number of periods and I took the years and compounds per year and multiplied them. So that's a calculation. This one here, I took the payments, took the interest rate times the face amount divided by the number of compounds per year to figure out how much the interest payment was individually. The future value, I'm not calculating, put that in. I put a 0 in because all the bonds we're doing would be a 0. So that's how you figure out the price of a bond. That's how you figure out the value of a bond, whether it has a premium or a discount as well. I'll stop there. And like I said, if you need additional help with this, I have other videos that I have done on time value of money.